Okay, got a polynomial p of x, and here it is. Okay? Now we know from what we did for homework that if you multiply all these out, you get a sum of multiples of powers, whole number powers of x. Okay? And that's another standard way to write the polynomial, but the way we really want to work on the polynomial is in its factored form. You can't do much with it unless you have it factored. Okay? And since they're hard to factor, I'm just going to give you the factored form. You should be able to factor a quadratic. Okay? Try no more. But other than that, I'm not going to be too picky. Okay, so. Okay, can you solve p of x equals 0? Now you should, just by looking at that equation, be able to tell me one solution real quickly. What do we mean by solve p of x equals 0? This means find a value of x that makes it 0, right? Okay, that's what it means. So, can anybody give me just one value? 5. If x is 5, that makes this 0. And since everything else is multiplied by this, makes it all 0. Okay? And I'll write the rest of the statement just to be complete, okay? Okay, what else?
-3/2.
-3/2, because that gets a little more tricky. We can say, well, okay. P of x is 0 if 2x plus 3 is 0, right? Just like it was 0 if x minus 5 was 0. So your solution is x equals -3/2. If x is 0, x equals -3/2. Okay? And then also if x squared minus x plus 4 equals 0. Okay? But that ain't so for any real value of x. If you understand quadratic functions, you understand why. Plug that into the quadratic formula, you're going to get a negative under the radical. Your discriminant is going to be negative. So we're saying the same thing. And you're not going to get a real solution. Okay? Now, for any other value of x, let's be more specific, other than x equals 5 or x equals -3/2, x minus 5 is not 0, 2x plus 3 is not 0, and x squared minus x plus 4 is not 0. Okay? So x minus 5 times 2x plus 3 times x squared minus x plus 4 is not equal to 0, because you can't multiply three things that aren't 0 and get 0. The only way you can get 0 by multiplying a bunch of numbers together is for at least one of them to be 0. Otherwise you get something that isn't 0. That's common sense. Okay? And by the definition of 0. So I'm not going to try to prove that in more rigorous form, but it's common sense. And it's valid. Okay? Okay. Okay. So what does this tell us about P of x? What's it tell us about the graph of P of x? So what do we know? We know that when x equals 5, P of x is 0, which means we have a point on the graph. What are the coordinates of our point? 5, 0, right? So now, five, 0 is a point on the graph, and so is what? What's another point we're sure of? -3/2, 0. Okay? So we know we've got these 2 points. We also know that the graph doesn't go through the x-axis anyplace else. How do we know that? Because if it did go through the graph someplace else, it would be, P of x would be 0 at that value. And it can't be. Okay? So, make an incorrect statement because I'm not thinking. Yeah, rewrite it. Zeros occur at these points and nowhere else. Okay? Now what's another point on the graph that we could easily find? Now, is there a number we could plug in for x other than 5 or -3/2 to be really easy to evaluate? 1 would be easy. What's easier? Zero. You plug in 0 and everything disappears except that -5, that 3, and that 4, right? Because everything else has an x, or power of x. It's going to be 0. Okay? So, I'm going to say the y-intercept occurs at the point 0, p of 0. That's just a fancy way of saying if you plug in 0, you're going to get the value of p. It's going to be at the point 0, whatever you get, right? So plug in 0, and it's easy. -5 times 3 is -15, and -15 times 4 is -60. So now we know that the graph is going to be at -60 when x equals 0. So we get the point (0, -60). Now, what else do we know? Well, if you change x by just a little tiny bit, then y is just going to change by a little tiny bit. And the tinier the bit you change x by, the tinier the bit y changes by. Now, that's not a rigorous argument, but we can then conclude, after a little bit of more advanced mathematical arguments are beyond the scope of this course, that we have a smooth graph, a continuous graph. You go from one point to another without jumping. Okay? So, I'm going to have a continuous graph, and it turns out the graph is smooth. It doesn't have any jagged edges on it either. Okay, just like the graphs that we've been drawing for the basic functions. It's just as smooth as those are. Okay? So that means that somehow we've got to get from here through here and back to here. But it's not going to do that because if it did, then if it had a bunch of wiggles in it, then we could lower the x-axis just a little bit and we'd have a bunch of zeros, right? But that would be equivalent to just subtracting a number, some small number from what all this multiplies out to. And now we'd have one of these that has a bunch of zeros, and that can't happen. Now, that's an argument I'm not going to be responsible for right now. But for that reason, we figure the graph goes down through here, turns around, and comes back up through here. Okay? Got to do something like that. It's going to hit a low point someplace. So I just kind of made this almost like a parabola, but it could be skewed this way or that way, and it would be skewed one way or the other. So the low point wouldn't be exactly halfway between these, but the low point wouldn't be right here either, at least very unlikely that it would be. Okay? So the low point's going to go in here somewhere, and you're not sure where. Now you learn just a little bit of calculus and you figure out how to find that point. But this is pre-calculus, we're not going to do that. Okay? But it's one of the easier things to do in calculus, at least for cubic functions. Okay, so we know this much though about the graph. So there's a whole lot of information that we have that we didn't have before we did this few simple steps. These few simple steps. That's what we grammatical. Okay? Now, what's it do after it goes through here? What's it do after it goes through here? Well, after it goes through here, the value of p is going to become positive, okay? Because you can figure that out. If p is bigger than 5, then this is positive, and this is positive, right? And if p is bigger than 5, well, p is 5, you got 25 minus 5 plus 4, right? It's 24. So all these would be positive as soon as p gets bigger than 5. And then this just keeps getting bigger, and this just keeps getting bigger, and this just keeps getting bigger. So you got 3 numbers that you multiply together, and they just keep getting bigger as your x value gets bigger. Okay? Now, there's more we can say about that, and we will, but for right now, we're just going to say, well, this is just kind of keeps going. Okay? And then to the left of negative 3/2, for numbers less than negative 3/2, this is going to be negative. Okay? Because if x is bigger than 3/2, this is positive. If x is less than 3/2, it's going to be negative. And this is certainly going to be negative. Negative 3/2 minus 5. Any number less than negative 3/2 is negative, and any negative number minus 5 is negative. And the further x goes into the negatives, the bigger this number gets, but it's a bigger negative, right? And this number is going to be positive. You can check that out, okay? So you're going to have a negative here, you're going to have a negative here, and a positive here. It'll be positive. And as you go further and further to the left, all these numbers just get bigger and bigger in magnitude. They stay positive. The product stays positive. And the thing just kind of goes up like this. So it kind of almost looks like another boring old parabola, except it's not a parabola because the low point isn't halfway between the zeros and a lot of other things, okay? But one kicker is that the low point is not between the zeros. Okay. Now, I'm going to ask you for next time to do this much. I'll give you a couple other polynomials based on the letters in your name. Okay? But you're going to reason it out just like this. And if you don't remember how to reason it out, you've got a detailed video. And if you weren't here today, you've got a detailed video. You just imitate everything I did, except you don't want to look like me. But other than that, I mean, there are heights to which you just can't aspire. And you don't want to act like me either. So you don't have to do that. But imitate the reasoning process. Does that make sense? Do that.